Welcome to Module 3, Lesson 19, Unknown Area Problems on the Coordinate Plane. Yes, we are moving on to the coordinate plane once again. We were here some time ago, beginning of the school year, and we're back. Hopefully you remember a good deal enough about it that we will be able to move smoothly through this lesson. Well, let's give it a whirl. Okay, and here is our coordinate plane, okay, with its different quadrants, 1, 2, 3, and 4. X-axis being horizontal, it's going to be very important, and the y-axis, of course, as our vertical axis. Knowing those and knowing when to use those to measure, which is what we're going to do this lesson, will be very important as well. And of course, our friend, the origin, which is 0, 0, will also come into play. Okay, so with no further ado, let's get into an example here, area of a parallelogram. Okay, and parallelogram, as we know, is a shape that has, actually, I didn't want to mark those points quite yet. Let's go ahead and get that off of there. We'll get back to it. But yeah, parallelogram has two pairs of parallel sides. Okay, and that is going to distinguish it as a parallelogram. Okay, and we will see that. How important that is in future here. So, okay, so let's move further here. First thing we want to do is go ahead and we want to mark these points here because we're going to write the ordered pairs of each of the vertices next to the vertex points. Okay, now I am right here marking up these vertex points, as you see. Here's one of those vertices right there. Okay, here's another vertice, a vertex, okay, and vertex right there. So we are going to label those coordinate pairs of all of those. Okay, we could see, of course, as you remember, hopefully, that when we write an ordered pair down, we do it in the fashion of x, y. Okay. Over here you can see that -3, -4 is in that quadrant where everything is negative. Okay, just to make note of that. All right, and here we go. 5, 2. All right, and 2, -4. Really important here that we, when I was drawing those lines down to the actual axes. Important to be very, very careful about seeing exactly where that point lies. It's kind of difficult when you're using diagonal lines like this parallelogram. It helps a lot to draw. So if I'm drawing from A here, I'm drawing a line down. I can see that my x value is -3. Otherwise, I might see it as something else. I might even look to where the line crosses the x-axis, which would be incorrect. Okay, so there we go. We've written the ordered pairs of each of the vertices next to their vertex points. We're going to need all of these and then some. So let's hold on here. So we're actually next order of business here is coming up. Okay, now we're going to draw a rectangle surrounding figure P that has vertex points of A and C. Label the two triangles in the figure as S and T. Okay, so you're going to use A and C as two of your vertex points, okay, for this rectangle. Now let's see if you can imagine where you might fit in two triangles to create a rectangle, a larger rectangle. Okay, so here we go. Let's go ahead and make a rectangle, and there we go. We've made a rectangle making two actually equivalent triangles. Okay, they are exactly the same size, and we've labeled them S and T. So if you have something that looks a little bit different, or you're a little bit confused about this one, just go ahead and fix it up and make it look like this. Okay, our next task is to, they ask us here, is to find the area of the rectangle that we've just created. So I've gone ahead and just put it on a different sheet of paper. Maybe you can do the same on a piece of graph paper if you don't, if it's a little bit too messy for you there now. And what I've done is I've gone ahead and labeled my vertices, okay, because I'm going to need those to help me figure out my my base and my height, because that is the area of a rectangle, which equals base times height. So I'm going to need to know those measurements, and these coordinate actually ordered pairs, these points there, are actually going to help me do so. Okay, so let's go ahead and look at that first, the base. Okay, the base of this rectangle. Okay. Base of this rectangle. The horizontal line, we'll use x values, and we'll continue to do that throughout this lesson. When we want to find the length of the horizontal line, usually usually called the base here for our purposes, we're going to use the x values. Okay, and those two x values we're going to be looking at are -3 and 5. Okay, so what we can do with the -3 and 5 to actually figure out the distance between them, because we've done this in the past, is to calculate with the absolute value of -3 minus 5, okay, which is going to give us absolute value of -8, which gives us 8, and therefore we have 8 as our the length of that line segment, okay, that stretches from -3 to 5 as a value of x, okay? And yeah. Now the vertical line, okay, and that's going to be our height, all right, uses the y values, okay? The vertical line is going to use the y values, and we're going to use them in the same way as we use the x values, okay? And there we go. So we had -4 and we had 2, okay, for our y values. It doesn't matter actually which way you subtract, and we all might have learned that. Hopefully we learned that or saw that when we worked with this in the past. We worked with the absolute value. Absolute value of -4 minus 2 is going to be the same as the absolute value of 2 minus 4, okay? So they're going to be the same. So we have, or 2 minus -4. Yeah, which is ends up to be 6. Okay, so our absolute value is 6 here. So therefore we have our height as well. If we go ahead and plug in, use our formula, area of a rectangle is base times height. That means it's going to be 6 times 8, which is going to give us 48 square units for our rectangle. Okay, let's go ahead and fill that in part C here. Area of a rectangle is 48, the floor of our rectangle is 48 square units. Okay, so in letter D, it asks us to find the area of each triangle. Now you can go ahead and just figure out, or just calculate the area of one of those triangles, and you'll know the other, okay? So, yeah, give that a whirl and come on back. All right, so step number 1 is to go ahead and plot those vertices, okay, to know where they are, and we're going to need a few more as well, because we need the bases of these two triangles. So we needed a couple of more ordered pairs to write, because we're going to need those when we're figuring out the lengths of the bases of those triangles. Okay. So there we go, just write our area of a triangle formula, which is half base times height. Talked about this, I think, last lesson. I'm sure you've talked about this quite a bit in your lives already, in your math lives. Okay, so let's go ahead and figure out that first, the base of, we're working with triangle T, and we'll only work with triangle T now because we know triangle S is going to be equivalent, okay? So we went ahead and figured out the length of the base, and you can see we had, I took the two x values, which were 2 and 5, and absolute value of 2 minus 5 is the absolute value of negative 3, which is, of course, 3. Would have worked, again, the opposite way. It could have been absolute value of 5 minus 2, which would have been absolute value of 3, which would have been 3 as well. Okay? All right, now we're going to look at that height. Look at the height measure. We're using x values now. And we have, for the x values, we're using our 2 and negative 4. I'm sorry, we're using the y values. We use x values for the other one. We're using y values, which are 2 and negative 4. So 2 minus negative 4 is actually 2 plus 4. Absolute value of 6 is 6. And therefore, our height is 6. Base of 3, height of 6. And we go ahead and plug in our formula. And yeah, half of 6 times 3 is half of 18, which is 9 square units. So we have 9 square units for triangle T, and as triangle S is equivalent, it would also be 9 square units as well. Okay, so now let's write those in. We have the area of each triangle is, there are 9 units square, 9 square units for S and 9 square units for T, because they are equivalent. And now we're going to go ahead and use these areas to find the area of the parallelogram ABCD, which was our pursuit from the beginning. It's an odd-shaped figure, so we're decomposing here we're actually constructing to deconstruct. Something interesting. Anyway, we're doing. Anyway, yeah. So here we go, and we have 48 units for the entire rectangle. The two triangles add up to 18 square units together. Therefore, if I'm going to find the area of that parallelogram that is between those two triangles, I'm going to take that whole rectangle's value, which is 48, subtract away the 18 from the triangles, and I'm left with 30 square units, which is the area of that parallelogram. All right, so here we go. We have our parallelogram all filled in right there. And we could just go ahead and just plug in our values that we found out. We found out that the entire rectangle was 48 units squared. We had two triangles that were 9 each, and they were 18 units squared total, which would have made our parallelogram equal to 30 units squared. Okay? Fun way to solve a problem. Okay, so this coordinate plane below contains a figure R, and it's a rectangle with the same base as the parallelogram above, or I guess it's above in your binder, but it's the parallelogram that we just worked with. Okay, it has that same base. It shares that base AD. Okay, right here, your pursuit right now is to draw triangles S and T and connect to figure R so that you create a rectangle that is the same size as the rectangle you created on the first coordinate plane. Okay, so you're trying to create a rectangle that is the same area as the one we just did. Okay, adding two triangles, S and T. And I'm going to just request that you add them this way. Okay. Anyway, go ahead and give it a try. Come on back, and you can see what I did. Okay. So very simply, I created S and T just like that, which are both similar sizes, and I made them the size that would be comparable to the size of the rectangle we made before. So if yours looks like that and yours has an area of 48 square units, then you have created a good rectangle. You may have done it to the left, possibly. It's not a big deal. I just thought we'd try to keep it simple by keeping it consistent. Okay, we're going to go ahead and use these base measurements. Okay, use the base measurements, and if we need, actually we might not need them quite yet. So let's just hold on a second there, because the first thing we're going to do actually here is we're going to find the area of rectangle R. So go ahead and find the area of rectangle R, and come on back after you're done. Okay, so yeah, we are actually finding the area of rectangle R. Okay, and very, very important that it was R we're looking for. It wasn't the whole large rectangle we made yet, just rectangle R. Okay, and so we of course need our base, and we can see that our base is 5, and we know it's 5 because it's the same base as the parallelogram from before. Okay, 5 units, and our height, of course, was 6, as we can see that if we go ahead and look at the vertices at A and above A there. Okay, is 6 units, and then if we go ahead and do our 6 times 5, we get an area of 30 square units, which should look familiar because that was the same area the parallelogram from the last problem had. Okay, and if we look further, we can look at that larger rectangle, and we can see that it is, again, 48 square units, which proves that we have a rectangle that is exactly the same, has the exact same area as the last rectangle we made with the parallelogram. And there we're going to have the two triangles are going to be both 9 square units, just like they were in the last problem as well. Okay, so the next question we're asked is, what do figures P and R have in common? And again, the P was that parallelogram right there, and R, as you see, is that rectangle. Well, for one thing, they share the same base. Okay, the exact same base is located in the exact same position on the coordinate plane, and then they have the same height. Okay, they are both. We have 6 units high. Okay, and we can see that as well. And again, stretching from the same between the same two y values. Right, and then. Therefore, they have the same area, okay, and that area was 30 square units. Okay, so hopefully you are you've caught on and you understand how to use these the coordinate plane and the ordered pairs to get the measurements that you need. So we can try to go ahead and blow through these exercises here, one at a time. So go ahead and look at these 1, 2, 3, 4, and 5, and we will come back and we'll do them together, correct them together one at a time. Okay. So if you want to do them all right now, you can, or you can pause in between. Okay, so number 1 is asking us to find the area of triangle ABC. Okay, so what I want to do firstly is I want to go ahead and write out my formula for the area of a triangle, which is 1/2 base times height, and there is my base right there. And if I look at my ordered pairs for my base, or the horizontal line, goes along with x values, I will see that I come up with -3 minus -4, well, absolute value of -3 minus -4, which is the absolute value of -7, which would be 7. Therefore, I have a base of 7. Okay, and now I can look at my height. All right, and my height I'm looking now at y values, and that is the 2 and the -2, and then 2 minus -2 is the same as absolute value of 4, which is 4. So I have my height as well. Okay, all I have to left to do is to do my multiplication, and if I do 1/2 times 7 times 4, and that's 1/2 of 28, and therefore I get 14 square units. Okay, so I get 14 square units for that triangle. Okay. Now the next one is number 2 here. Find the area of the quadrilateral ABCD. 2 different ways. Okay, one of those ways will will include deconstruction or decomposition, and the other is kind of a secret. So if you want to go ahead and do it one way first, because you might not be able to do it a second way, that second way you'll be quite thrilled to see it. Okay, so we're going to find the area of the quadrilateral ABC 2 different ways, and like I said, let's just stick with one, and that first way is to decompose. Okay, we're going to go ahead and decompose this trapezoid. This is a trapezoid, fondly known as a trap, and we've actually separated it now into 3 more friendly shapes, which are 2 triangles and a rectangle. Okay, so let's go ahead and plot some points, these different ordered pairs that go along with all the different points that we are going to need to do our calculations. Okay, so first we'll go ahead and calculate the area of that first triangle. Okay, and there we go. Doing all that, so I know that my triangle formula, 1/2 base times height. I have 1/2, and then I'm going to go ahead and figure that base out, and that base starts at point A, goes over to the next point, the point next to it, and figure that out by subtracting my my x values, because x is my horizontal marker. Okay. And now I'll go ahead, and that was those 2 x values. Now I'll go ahead and get my height using my 2 y values. Okay, and that's 3 and -2. Okay, 3 and -2, and therefore I get 5. So my formula is ready to be finished up. Okay, because if I have half of 2 times 5, which means I have half of 10. Which is 5 square units. Okay, 5 square units is that green triangle there. Okay, so next triangle, same triangle formula, and we know we've already calculated or figured out their height, the height of that triangle, because it's the same as the other, so that's 5. Now we have to just work with the base, and we do work with the base. We can work with again with our x values. And we get 1, okay? And now half of 1 times 5, which is half of 5, is going to be 2 square units, okay? So now we have 2.5 square units for we'll call that the white triangle. Okay, so let's just go ahead and recap there with our triangles. 5 square units for the green one, 2.5 square units for the white one. Only thing left now is now we have I was calling it a blue rectangle, okay, which is very simply base times height. Okay, and we have our height already. Again, for all of these, very convenient. We have 5. If we go ahead and find our base using the x values, that is 2. Therefore, 2 times 5 is 10 square units. Okay, one thing left to do, all right, is to add them all up. 2.5 plus 10 plus 2.5 equals a grand total of 17.5 square units for this trapezoid. Okay, and hopefully some of you were successful with that. And there it is. Okay, there is a second way, and that way is the trapezoid area formula. Okay, and if you want to, you can write that down right now, but later on at the end, one of the last slides, I will have all of these area formulas written out, and you can write them in your book as well, and they actually might be in your binder already. I'm not quite, yeah, I think they actually are. So, or maybe not. Anyway, there we go. There is our trapezoid area formula. We have two bases in a trapezoid, as you see. We have, in this case, it's they are denoted or marked by line segment AD and line segment BC are our two bases. So we're going to find those two bases, add them together, take half of that, and then multiply all of that by the height. Okay? All right, so let's go ahead and find those ordered pairs. Okay, very, very important to find those ordered pairs because they are going to be our key to solving this. So let's go ahead and figure out base 1. Okay, and that base 1, we'll call it base 1, is 5 units long. And again, that's from using my two x values. Absolute value of -3 minus 2, which is the absolute value of -5, which of course is 5. Okay, let's go ahead and look at that second base, and that is 2. Again, calculated the same way. Absolute value of -1 minus 1, which is absolute value of -2, which is 2. Okay, and there we go. All right, and now we know that our height is we've calculated our height as 5. Okay, the height of this is 5. We can see that just by looking at it, because we can use our two y values. Okay, we have a y value at the bottom of -2 and a y value at the top of 3. Okay, so -2, or absolute value of -2 minus 3 is absolute value of -5, which is, of course, 5. Okay, so now we have our formula all ready to be figured out. And again, we're talking about what we need to do what's inside those parentheses first. So we are going to therefore look at that parentheses, which is 7. Okay, 5 plus 2 is 7. So half of 7 is 3.5. And then we're going to go ahead and multiply that 3.5 times 5 to finish off our formula, because that's the height value. And we get a grand total answer of 17.5 square units, which is exactly what we got last time. Okay, but a lot more quickly, okay, with a lot less steps. So that's the trapezoid area formula. Maybe a lifesaver for you guys one day. Okay, number 3 here asks us to, don't want to quite do that. That's pretty, oh yeah, this is messy, huh? Let's go ahead and get rid of all that. That's all this. This is really messy. Sorry about all that. Anyway, let's just start from here. Okay, so we are going to try to find out the area of we're being given the area of the quadrilateral ABCD, and we are being told that it is 12 square units, and we are going to find x. Okay, we're going to find x, and we are going to use our formula right here, which is A equals B times H, which is area equals base times height. And we are going to plug in what we know, and we will do our solving algebraically. Okay, so let's go ahead and plug in what we know, what we've been given. We've been given the fact that area is 12 square units, so we can plug that in for the A in the formula. and so that means 12 equals base times height. So we've got the base, which is 2, because that's pretty simple to look at right there. We go from A, which is 1, to point B, which is 3, and therefore we know that's a base is 2. Okay, but now we're going to solve for x, which is our height value. Okay, so if we know 12 is equal to 2 times x, we just substituted the x for the h. Okay, that could also be written as 12 equals 2x. And it can also be written as 2x equals 12, okay, which is our very familiar way to write it for us, okay? So if we know that, we can do this algebraically. You can look at it. I'm sure you can get the answer right away. But if we do it algebraically, okay, we can go ahead and multiply both sides by the multiplicative inverse of 2, and that is 1/2. And we end up with x equals 6. So x, or the height of this parallelogram, they're calling it quadrilateral. Of course, it's quadrilateral, but it's parallelogram as well. The height is actually 6 units. Okay, and then if we can plug this in here, and we know that 6 is going to be our height. And then if we go ahead and plug in 6 for the x over there, we know that the area of this parallelogram or quadrilateral is base times height, and then 6 times 2 is indeed 12 square units. Okay, so now we are being told that, I'm going to pause that actually. Now we're being told actually that the area of this triangle ABC is 14 square units. And what we want to find is the length of side BC. Okay, we're going to find the side BC, which happens to be our base. Okay, so the way I started off here is with my area of a triangle formula. A equals 1/2 base times height, and I plugged in what we know. We already know the area, which is 14. So 14 equals 1/2 base times height. Okay. And 14 equals 1/2 BC, because that's our base times height. Okay, we'll just replace the B with the BC, that segment. Okay, and yeah, if we go ahead and then we're going to look and we're going to see that see what the height of this triangle is. Okay, we can see see the height of it by extending it out into a 90 degree angle. Okay, and if we do that, we don't need actually ordered pairs. We only need the two y values at the vertices. Okay, so we have -3 at the bottom of that right triangle, and then 4 at the top. So that is equal to 7. Okay, so absolute value 4 minus -3 is absolute value of 7, which is 7. Okay, so now we have 14 equals 1/2 BC times 7. So what is that BC going to equal? Okay, well, if we know that this 1/2 times BC needs to equal 2, because we know that 2 times 7 equals 14, okay, the only way that it can equal 2 is if BC equaled 4, okay? So BC has to equal 4 for it to work. Now we can go ahead and plug that in and see if that works out. And it does indeed, okay? 14 needs to equal 1/2 times 4 times 7. So 1/2 times 4 is 2 times 7 is... Okay, so here's our last one. Real complicated looking one that will take multiple steps, but we are really close to making this a great, pretty speedy session here. So let's go ahead, and you're going to go ahead. You are being charged with finding the area of triangle ABC. Okay, and the way to do that, of course, is to take this thing apart piece by piece. Okay, so go ahead, good luck. Could take you a few minutes, but come on back and we will do it together. Okay, so here's what we're trying to find. We're trying to find the area in square units that will fill that ABC triangle, okay? So, firstly, good idea is to go ahead and let's go ahead and find the area of this entire rectangle first, okay? And the way to do that is to plot our ordered pairs, okay? Because we can use those ordered pairs to help us out, and that has really been the gist of this entire lesson. And hopefully, you guys are getting more and more comfortable with doing just that. Okay, so we know area equals base times height. We're looking at the area, of course, of this this rectangle. All right, and if I go ahead and use my values for my my x values on the base there, I would get 11 because negative 6 minus 5 is negative 11. Absolute value of negative 11 is 11. Okay, and then if I do the same with the height of this rectangle, okay, using my y values, 6, absolute value of 6 minus negative 4 is the absolute value of 10, which is 10, okay? So I can just figure that out, and I know my area is 110 square units. Let's go ahead and put that over to the side over there, just so we can remember that. That is the area of the entire rectangle in which that blue triangle resides, okay? So now we're going to use this triangle formula quite a bit, 1/2 base times height, because I have a lot of, we only have three triangles here to figure out, okay? So let's go ahead and do this one first. I've just outlined in red, all right? And so half, we know 11, because we know that base. We've already calculated that base when we found out what the area of that rectangle was, and that was 11. And then to go ahead and figure out our height, we know our height is 10 by using the y values, okay, 6 minus negative 4, and we've already actually done that on the other side as well, okay? So we have that, so that is 10, but if we're going to find the height of this rectangle, we're going to need to look at those the y values between t and c, okay? And if we do that, we get 5, and as you can see very conveniently, that is exactly 1/2 of the entire height of this of the rectangle, okay? So that little red outlined triangle is ready to calculate here. And so we have 1/2 of 55, because that's 1/2 of 11 times 5, and that equals 27 and a half, or 27.5 square units. And let's put that over there in red to the left, so we can keep track. All right, and so next we are going to do our green outlined triangle. All right, and we know already that we have the height is 10, okay, the height of 10, because we've already calculated that. And now we're trying to look to see what our base is. And our base, we can go ahead and plot another point. And if we do plot that point, we can go ahead and use those x values. The absolute value of negative 6 minus 1 is the absolute value of negative 7, which is 7. Okay, now we have our base. And all we need to do is calculate. Half of 7 times 10, which is half of 70, is 35. And again, we put that over to the left as well to keep track. One more triangle to tackle, okay? And we are, we can see that as we know the entire base of the entire rectangle is 11, and we already have 7 figured out. We know that that is going to be 4. The base of our rectangle, the base of our small triangle is going to be 4. And we know that the height is going to be 5 because we've already calculated the entire height. And then all we have to do is take away the height of the red triangle. Okay, and we know that's 5. So half of 4 times 5, which is half of 20, is 10. And put that on the other side as well. And now we're going to add up all of our, and now our total, the total rectangle, of course, again, is 110 square units. If we total up our triangles, okay, we have 72.5 square units. And then if we go ahead and subtract the triangles from the entire rectangle, we are left with 37.5 square units for the blue triangle. Yes, lots of work, but if you were successful in any way, shape, or form, I am sure you are elated, and I am very, very happy for you. Okay, so let's go ahead and close this lesson. Okay, so one thing hopefully you learned is that a coordinate plane can be useful, or a useful tool, in calculating area of shapes by using coordinate points, or what we call ordered pairs, to measure base and height. Okay, we'll probably see a lot more of this in the future, and I'm sure you will as you advance in your algebra studies. Now here are those area formulas I was telling you about, and if you don't have these down somewhere, and if they aren't in your binder, because I'm not exactly sure, I should be sure. Oh, they actually are, aren't they? But let's just go over them anyway. Parallelograms, okay, and rectangles, okay, and rectangles are parallelograms, and quadrilaterals, okay. Everything four-sided that's closed is a quadrilateral, okay. Not all quadrilaterals, of course, are parallelograms, but all rectangles are parallelograms, okay. But not all parallelograms are rectangles. Anyway, the formula for those are base times height. Those are simple ones. Now, triangle formula is a half base times height, because we've seen the relationship between quadrilaterals and triangles, and a very happy relationship. Yeah, triangles are half of the others. Now the trapezoids. Here's the trapezoids. That's the fancy one. That could save us a lot of time and a lot of steps in the future. And that's 1/2 of the base 1 plus the base 2. And take all of that and multiply it by the height. Okay, and remember, one more thing. Deconstruct or decompose a shape into shapes for which you have area formulas. Okay, area formulas. That should be area there. Take that S off. Okay, yeah, deconstruct. Because what do we always try to emphasize whenever we do anything, especially in math, is to use what you know and go from there. Okay, use what you know and go from there. Okay. Hopefully you had fun with these, and hopefully you find these the problem set equally as fun. If anything ever gets too challenging, slow down, take a deep breath, give me a call, send me an email, and we can work it out together. Okay? Well, thanks for watching, and see you soon.